9 station review, unit 7, part 2, stations 4, 5, and 6 in this video. For the following compounds, draw the Lewis structure, identify the shape, and predict if the compound is polar. Here we go again, CH4, everybody, my goodness. How many times are we going to see CH4? The shape is going to be shape A. Is it polar? Again, ask yourself, are there strong and weak bonds here? Strong and weak interactions, I should say. No, there's not, so it's not polar. No, it's not. N2. N2 again looks like this. The shape for N2 looks a whole lot like either F or G. I'm going to go ahead and go with G. No, well, it's a tough one because G is polar, F is not. If you said either or, F or G would be correct. Okay, F or G. I'm not sure which one is the correct one for this particular activity, but F or G, both are linear. Okay, so either or will work as long as it's linear. Is it polar? Well, that's strong and that's strong, but two strongs cancel each other, don't they? So no, it's not polar. CH2O. Let's draw that one again. It looks like this. There's your H. There's your H. Connect those. And that gives you two bonding sites for O. Right? So CH2O. Let's clean it up a little bit and draw it over here. CH2O. Looks like that. Okay, we've got a strong here, weak there. That means it's going towards the strong. There's nothing to cancel out this strong weak interaction. There's no other strong bond over here. Is it so as far as the shape goes, let's look and see. Now this is a little bit of a tricky one. The shape is actually, the correct shape is actually letter D, and the reason why is, let me draw it on the back. Okay, the reason why is, let me try to draw it the way we had it before, like this. Okay, H and H. If I were to do the model of this, it would be 120 degrees. You know what? Let me just do the model and I'll show you. Okie dokie. CH2O. There it is right there. Looks a lot like this. There's your double bond, and then there's your single bond to two hydrogens. This angle right here is 120 degrees. 120 and 120, roughly. So, what shape does that correspond with? It corresponds with shape D. CH2O corresponds with shape D. That's a tricky one. Is it polar? Well, you've got a strong and weak interaction here. And this molecule is, the oxygen's pulling all the electrons toward it. So, and there's no other oxygens on this side to cancel that out, right? On either one of these sides to cancel that out. So, is it polar? Yes, it is polar. That's CH2O. Okay, H2O. This is station 5 now. Station 5. H2O. God, you guys, you got to just memorize this. H2O. There you have it. Shape of H2O right there. Shape C. Is it polar? Well, yeah, of course it is. Hydrogen bonds. We spent a whole lot of time talking about that. NH3 looks like this. Well, first of all, what shape is it? It's the only shape that's got 3 legs and a lone pair. That's shape B. And is N a strong molecule or a strong atom? Yes, it is. So N is pulling all the electrons toward it, right? It's going towards N in this direction, towards N. Is it polar? Yes, it is polar. All the electrons are being pulled towards N. Silicon tetrafluoride. Seems like we've seen that one too. Fluorine. Okay. And there's 4 more of these fluorines. So I'm just going to draw it like this, you guys, just to speed things along here. Why didn't I draw these? You can, okay? I just didn't to speed things up. Now, oops, that's silicon. Okay, so check this out. strong, weak. That means electrons are being pulled towards the strong end. Strong, weak. Same thing in the opposite direction. This way and also that way. So you should note that all of these fluorines are canceling each other out. The shape is A. Anytime you've got a carbon or a silicon with 4 legs on it, it's going to be shape A, guys. The shape is A. And is it polar? Well, again, let's go back to this idea. That bond cancels that bond. This bond over here is canceling that bond there. Okay, so is it polar? No, it's not polar. Station number 6, types of solids. Here's what I'm going to suggest you do on types of solids. Do metallics first and ionics. Metallic. Brass, which is zinc and copper. Metallic. Copper. Metallic. Any other metallics? I don't see any. Okay, now ionic. An ionic solid is going to be a metal and a non-metal. So ionic solid. Oh, here's a metallic. Aluminum oxygen, ionic solid. Lead oxide, ionic solid. Now that you have those out of the way, now you can focus on, well, network covalent. I would do next is network covalent. Again, you see them over and over again. Here's diamond, quartz, graphite. So that's network. There's only like 3 or 4 examples, you guys, that we're going to encounter. I think this is it, unless I'm mistaken. Those are network covalent. That's done. Well, then the rest of them are going to be molecular solids. So that's going to be molecular. Water, whenever it's in solid form, when it's ice. I've never seen solid chlorine before, but I guess it could exist under the right conditions. It would have to be very cold conditions with low pressure. Anyway, there's molecular. That's a molecular solid. Okay? And that concludes station 6 and video 2. Next video is going to be station 7, 8, 9.